Hi, in this video we are going to solve a quadratic inequality. The question is to solve the inequality x squared plus 3x minus 4 greater than 0. And we're going to do this using what's called the test point method. So solution. So in the test point method, the first step is to get a single term on one side and 0 on the other. In this case, we have 3 terms, so we somehow have to turn this into one term. To do that, we're going to factor. I'm going to start by numbering the steps. So here's step 1, just writing down the problem one more time. And we should be able to factor this. So let's see. What multiplies to 4? Well, 1 and 4. And it looks like the 1 should be negative and the 4 should be positive. And we can check that. X times x is x squared. 4x, that's the middle term, plus negative x, that's the outer term, is 3x. And 4 times negative 1 is negative 4, so it checks. Okay, so the next step in the test point method, right, this is a procedure called the test point method, is to set each of these factors equal to 0. This is not an algebraic step. I want to emphasize that, right? It is not true that if you have this, then this is true, right? This is not a valid mathematical deduction or it is not a valid logical step, right? This does not imply what I've written down. You might say, why did I write it down? Well, we're following a procedure, and in that procedure, this is the next step. So now we solve each of these simple equations for the value of x. Here we get x equals negative 4, and here we get x equals 1. At this point, we go to the next step. In the next step of the test point method, we take these and we plot them on a number line and we pick test points. So here's negative 4, and here's 1. And we take our test points and we can plug them into the original equation or this factored one here. I'm going to choose the factored one. So how it works is the following. We're basically going to pick a number over here in this subinterval and we're going to plug it in here. If this is true, we shade. If it's not true, we don't shade. Then we do it again. We pick any number between negative 4 and 1. So we're going to pick 0 because it's easy. We plug it in here. If it's true, we shade. If it's not true, we don't shade. And then we do it again. We pick any number over here bigger than 1, plug it in here. If it's true, we shade. If it's not true, we don't shade. All right, so let's pick negative 5 because it's easy. So I'm going to say check negative 5. So we're going to take negative 5 and we're going to plug it in here. So it'll be negative 5 plus 4, negative 5 minus 1. And we want to know if that's greater than 0. So negative 1 times negative 6. We want to know if that's greater than 0. So 6 greater than 0. Is that true? Yes. Yes, indeed it is. 6 is a number bigger than 0. So we shade this. Now let's check 0. And I'm going to go ahead and write down the problem again down here so we can see it. Right, this is where we're plugging stuff into. Let's check 0. So we get 0 plus 4. 0 minus 1. We want to know if that's greater than 0. That's 4 times negative 1. We want to know if that's greater than 0. So negative 4 greater than 0. No, that's super bad, super wrong, not true, so we don't shade. And last, and certainly not least, we're going to pick any number over here bigger than 1. Let's go with 2. Again, you can use any number you want. You can use 10,000. So 2 plus 4, 2 minus 1, and we want that to be greater than 0. 6 times 1, greater than 0. 6, greater than 0. Yes, that's true. Because it's true, we shade. So now from here we can get the answer. Because we have a strict inequality, everything is parentheses, and from here we can get the final answer. It'll be negative infinity to negative 4, union, and then 1 to infinity. And you can put the parentheses here for added clarity. And that would be the final answer. I hope this video has been helpful and hopefully you've learned some mathematics. Take care.